We'll put you in a maze, and you will have to learn from it. You are built for a great purpose, so do make us
Teammate, fight!
To reduce the noise caused by the power supply, we added a bypassing capacitor to the circuit. We also soldered three 0.1 microfarad ceramic capacitors across the motor terminals to minimize the effect of motor noise to other parts of the system.
The most critical part of the robot movement is the accuracy, and the basic element here is the PID. To increase the robustness, we adopt the auto-calibration, which includes two parts. First, make sure the robot keeps the correct distance from the wall and the obstacles, and the second one is to make sure the robot keeps parallel to the wall and the obstacles.
For calibration of our sensors, by making use of standard libraries, we add a range of offset parameters to make our final readings more accurate and robust. We're using an object-oriented approach to separate different functionalities to different classes. We're also using a configuration file so that if any changes are made on the actual hardware, we can simply update the config without touching the actual implementations.
The Android tablets work as a remote controller for the robotic system. It will issue various commands for the robot to move step by step manually or to explore the maze automatically based on its algorithm implemented. The commands will be transmitted to the Raspberry Pi via a Bluetooth connection, and the ARC Pi acts as a middleman between the Android tablet and the robot.
The Raspberry Pi is the command center in our robotic system. It connects to the Arduino board through serial connection. It connects to the Android tablet through Bluetooth, and it connects to PC through Wi-Fi. We have a multi-threaded design in our Raspberry Pi to make the communication through various devices possible.
Yes, and we designed a main thread that contains a message queue to store the incoming and outgoing message. The format of the message we use is string, and we have designed for the message to have 3 letters to be appended as identifier of the source, destination, and the type of the message. Some of the messages will be either processed by the algorithm or passed to the other devices.
In our simulators, we designed our robot using 3x3 cells. This is to give allowance of the robot and the obstacle in the real environment. We also place 3 sensors in the front to let the robot for advancing, and also we place 1 sensor each on the sides, which allows for calibrations.
So for the short impact algorithm, we use a Lee algorithm to find a short impact between 2 points in the base. You can imagine that it works like a wave keep expanding. To do exploration, firstly we assume that the map is free of obstacles. We use the short impact algorithm to make the robot to go from the initial point to the goal point. If the robot encounters any obstacle in a head and it cannot move any further, it will omit the path and recalculating a new path until it reaches the goal point. Then we find the nearest unexplored target and then keep moving until we explore the whole maze.